Hello, in this video I'll do section 13.4. The topics is flaws of apportionment method. Okay, flaws of apportionment. And in this flaws we have three types of flaws. The Alabama paradox. Number second is the population paradox. Population paradox. And number three is the new state paradox. Okay, the new state paradox. And these all flaws are flaws of apportionment method is for Hamilton method. We didn't do flaws for Jefferson, Adams and Webster method. Therefore my point is, if you are doing this section 13.4, you should know how to do the apportionment using Hamilton method. Okay, alright, that's the first thing you should know. Okay, uh, before I do the example, let's talk about the first plus Alabama paradox. Alabama paradox occurs when a state loses a seat as the result of an increase in the house size or quota. Okay, in other words, if you increase the quota from one number to another number, by the time one of the group loses the quota or house size or number of allocated item, whatever you call, that's called Alabama paradox. I'll do the examples and come back to this definition again to clarify more. Okay, number one, consider the apportionment of 40 doctors for physician organization. Okay, number of quota here is 40. Okay, the apportionment using Hamilton method is shown in the table below. Okay, the 40 doctor is divided among the group 1 2 3 4 5 group, which are the clinic, and they did Hamilton method for 40 doctor. See, 40 doctor. Okay, and for the 40 doctor, the Hamilton apportionment using Hamilton method is going to be: Group A got 9 doctor, Group B got 8 doctor, Group C got 7 doctor, Group D got 8 doctor, Group E got 8 doctor. Therefore, if you add all this apportionment, this sum to 40. Therefore, here for 40 doctor, Hamilton apportionment is done. Okay, for 40 doctor, this is the apportionment. Okay, this is the apportionment. That means A clinic has 9 doctor, B clinic has 8 doctor, and so on. Okay, now next part is complete the table below with new apportionment clinic for A, B, C, D, E using standard divisor and down to the 2 decimal places. That means using standard divisor means using Hamilton method. Remember that only we use standard divisor on Hamilton method. And you guys need to do the apportionment using Hamilton method for this clinic for 41 doctor. Remember that the number of doctor increased from 40 to 41. And this first table for for 40 doctor apportionment, let's do the new apportionment using Hamilton for 41 doctor. Again, I told you should know how to do Hamilton in this section. Therefore, my assumption is you know how to do Hamilton for this table. But I'm gonna just write down the final apportionment using Hamilton. Again, you can pause the video and do the Hamilton and check the your answer with this my number. Okay, by using standard divisor or doing Hamilton method, the 41 doctor is apportioned in that way. A clinic has 9 doctor, B clinic has 8 doctor, C clinic has 7, D clinic has 8, E clinic has 9. And if you add 9 plus 8 plus 7 plus 8 plus 9, they're going to be total 41 doctor. Okay, now let's do the comparison. What's the comparison? Let's see what happens. Is any group loses the item? Okay, for 40, let me do this way. For 40, for 41, okay? For 40, A got uh, 9, B got 8, C got 7, D got 8, E got 8. For 41 doctor, A got 9, B got 8, C got 7, D got 8, E got 9. Okay, this is the apportionment for 40 doctor from first table. That is done. Um, this is the apportionment for second table for 41 doctor, which we did, right? Now let's compare. Does any group loses the coda? Okay, 9 9 8 8 7 7 8 8 8 9. Notice that the coda for E increases, right? But none of the group loses the coda. If this happens, there is no Alabama paradox. Remember that Alabama paradox occurs when a state loses the coda. Okay, loses the coda. If nobody loses the coda, there is no paradox. But if something loses the coda as a result of an increase of the house size, here size increased from 40 to 41, but none of the group loses the coda, therefore there is no Alabama paradox. And how do you answer? How do you answer the question? Since no clinic suffer a loss, the Alabama paradox does not occur. Okay, that's the answer. Okay, let's do question number 2. Question number 2. The mathematics department has 30 teaching assistants to be divided among 3 courses according to respective enrollment. See, that's the table with 3 courses. And now let's answer the question. The teaching assistant using Hamilton method. Therefore, let's do 30 teaching assistant apportion among 4 courses. I'm sorry, about 3 courses: college algebra, statistics, and liberal arts math. Let me make a table for 30 teaching assistant. For 30 teaching assistant, what is a apportionment? College algebra, I put CA 7824, the population. Statistics, the population is 4,000, and liberal arts population is 2576. Okay, and the total, I don't have to write it down, but the total population is 14,400. This is enrollment. Okay, now let's do the Hamilton. Let's do Hamilton for 30 teaching assistants. I'm not going to do all the steps for Hamilton here because we did in previous section. You guys go back and check the video from last section how we did Hamilton. Okay, I'm writing just final apportionment using Hamilton for 30 teaching assistant, and then apportionment of teaching assistant using Hamilton method for 30 teaching assistant is gonna be this: 16. College algebra has 16 teaching assistant, statistics has 8 teaching assistant, liberal arts has 6 teaching assistant, and then we have this number here. Let me rewrite the number: 16 for college algebra, statistics for 8, and liberal arts 6. And if you add, total gonna be 30. Okay, total 30. Okay, that's for 30 teaching assistant. Now what happens? I use the Hamilton method to determine if the Alabama paradox occurs, if the number of teaching assistant increases from 30 to 31. Now you have number of item is 31. Okay, for what you're going to do here is you do exactly Hamilton method for this table with 31 teaching assistant. Therefore, use standard divisor for 31 teaching assistant. Again, you have to find the standard divisor equals to total population 14,400 divided by 31. Okay, and remember that in the for 30 teaching assistant use 30 as a number of quota, but for 31 teaching assistant use 31 as a number of quota because number of quota increases from 30 to 31. Okay, and if you divide this number you get 464.52. Okay, and use this standard divisor to do the Hamilton method for this table again for 31 teaching assistant. Again, this is the same as we did before in previous section, and if you do that, that's your apportionment. Okay, let me write down the apportionment here for 31 teaching assistant using Hamilton method. You'll find that college algebra will have 17 teaching assistant, statistics has 9 teaching assistant, and liberal arts has 5 teaching assistant. Okay, then if you add 17 plus 9 plus 5, which you'll get 31, correct? Okay, now we have a Hamilton method apportionment for 30 and 31 teaching assistant. Okay, now let's compare. The question is, does any group loses the item? Okay, let's see. Remember that college algebra, no, liberal arts math here. Look at the liberal arts. Okay, liberal arts math loses the quota. Make sense? Remember that before number of item was 30, liberal arts has 6 quota, correct? Now after increase 30 to 31, liberal arts loses the quota and other group gain the quota. Okay, that's called Alabama paradox. Remember that Alabama paradox occurs when the state loses the quota or seat as a result of increase in the house size or quota. See, we increase the size from 30 to 31, but liberal arts courses loses the teaching assistant, of course, by 1. Therefore, Alabama paradox occurs. The other group do not loses the quota, but liberal arts does. As long as one of the group loses the quota, the Alabama paradox occurs. Therefore, we're going to choose this. Yes, because liberal arts math loses the teaching assistant. See that here? Yes, liberal arts math loses the teaching assistant. Therefore, Alabama paradox occurs. Okay. All right. Question number 3. The population paradox. Okay, this is a longer question here, and look at the definition here. The population paradox occurs when a group A loses the item to the group B. That's a very important one. The group A loses the item to the group B even though the group A population grew at faster rate than group B. Notice that one of the group loses the quota or item to the group B, even that group which loses the item grew faster rate than group B. Okay, again I'll do the examples and I'll explain that for you guys. Okay, all right, let's do again this question. Again, you have a 2 table, one for the original population, another for new population, because we're talking about increase in population. Okay, therefore you're doing 2 different Hamilton method for 2 different table here, like we did previous section. Okay, question number 3. A small country has 24 in the Congress. Number of quota is 24 here. Okay, divided among the 3 states according to the respective population. The table shows the state population in thousand before and after the country population increases. Remember that this is the state A, B, C total population is this, and this the original population is the first table is original and the second table is new. Okay, new population is 1900, 9900. Original population is 8272. Correct? Makes sense? Now, part A. Use the Hamilton method to apportion 24 congressional seats using the original population. Now, use the original population, the first one here. Look at that, the first one. Okay? And use the Hamilton method to divide 24 uh, Congress or coda among these three groups. Again, I'm not going to do that because you know how to do Hamilton. Therefore, I'm just writing what's the apportionment for each group. Okay, for A you have a 4 coda, for B you have a 6, for C you have a 14. Okay, and if you add, you get 14 plus 6 plus 4, 24. That's the apportionment using Hamilton for original population. Notice that this is for original population. ORIGINL, original population. Okay, now let's see question number B. Find the percent increase to the nearest tenth of the percent. That means round it to one decimal place as needed. Remember that you have a new original population is here, new population is here. Okay, and the question asking for how much population increases from original to new. Okay, I'm going to do for A and B, C is similar. Percent increase for A. Let's do that. And how you do it? To do it, you divide the final minus original. In other words, you divide how much it increases. The final is for A is 1496 minus original is 1166. Okay, divided by original population, which increased from 1166. And if you do the math here, if you divide it, you get 330 divided by 1166. If you use a calculator, you get 0.2831. And if you changed it to percent, because your answer must be in the percent, it's going to be 28.3%. Therefore, the population of state A increased by 28.3%. If I'm going to put here 28.3. Okay, similarly you do for B and C, and let's see what's for B. Again, for you do exactly the same way I did for A. How much percent increase for B? For B, the percent increase is going to be 26.3. I don't have to type the percent here because the percent is already in the back here next to the box. And for C is going to be 14.7%. Okay, now for C you're doing Hamilton again for 24 congressional seats using new population. Okay, before you did the Hamilton for original population, now you have a new population that increases. Every group has some increase in the population. You have a new population, you use the Hamilton. Okay, therefore you use standard divisor again, use this total population divided by number of item 24 to find the standard divisor, and use the standard divisor to do the Hamilton method for this new population. Okay, now if you do that, you'll get this apportion. This A gonna be has a 3, B gonna has a 7, C gonna has a 14. Okay, and then altogether you have 24. 7 plus 3 plus 14 is 24. Okay, let's compare. does anyone loses the item to the group B? That's looking for that first. And even that group is growing faster. Okay, let's see. C, nothing happened to the C. 14, 14, C good, right? C good, C good. Because C, a portion does not change. But notice that, uh, see, A loses, a portion changes, and also B changes as well. Okay, B changes as well. Okay, what's the B here? 6. Okay. B, a portion changes as well. But a portion is decreases. A loses here, right? A loses. A loses. Right? Is that the paradox? Let's see. Even A is growing faster, and if it loses, yes, it is, because the question is, when a group loses the item to the group B, even the group is growing faster. Yes, this happens here because look at here, the population increase A with the rate by 28.3, with the B by 26.3. Therefore, look at here, A is growing faster than the B, but even A loses the item or quota. That's the paradox. Okay, just being less quota does not mean paradox occurs. Just losing the quota is not the paradox. Losing the quota, even growing faster. Okay, listen, A growing faster than B, and even A loses the quota. Yes, the the population paradox occurs. The answer is yes. The state A loses the seat to the state B, even the state A grew faster than the state B. Okay, but not about the C. C, nothing happened to the C. C is good, but only state A loses the seat to the state B. Actually, loses and B gain one more, right here. So that's the paradox. Okay. Question number 4. A company have 30,000 employee in 3 cities as shown is below, and it wishes to give a promotion to 200 employees. Therefore, 200 is number of promotion need to apportion among these 3 city employee A, B, C. Okay, and total population is here. Then what you're doing here is uh, you're doing pretty much Hamilton for 2 different population here. Uh, Here, this is the for the first one is the original population. Uh, Original population, ORIGINAL, original population. The new one here after 10 years. Okay, number of employees after 10 years. This is the new population. New population after 10 years. And we wanna distribute, or you wanna apportion 200 employee. You wanna apportion 200 employee among these 3 group using Hamilton for original population and new population. Again, you know how to do Hamilton again? You do the Hamilton and compare, does anyone loses the item. Okay, for if you do the Hamilton for original population, you get this: 61 for A, 41 for B, and 98 promotion for C. Total is 200, obviously, correct? Okay, now if you do the exactly same thing for the new population after 10 years, again, number of promotion is 200. Okay, you'll get 61 again, 61 for A, 61 for A, 40 for B, 99 for C. Okay, Again, let me rewrite that here. For A, B, C, 61, 41, 98 for original, and for the new portion, for the same number of promotion, you get 61, 40, and 99. Okay, now the question is, does anyone loses the group? Does any group lose the item? Yes, looks like the B loses the item. A is good here. A good, right? A good. A does not lose the item. Um, but B and C, let's see which grew faster. Notice that B did not grow at all, because look at the population, 60, 90, 60, 90. Okay, B did not grow at all. Therefore, percentage increase in the population B is 0%. Obviously, C population increases by some percentage, because the C original population is 14,770, the new population is 14,895. Therefore, looks like C grew faster than B, and C gained the item, but B loses. That's okay. That's not the paradox. Remember that. Even the paradox, population paradox, is the group A loses the item to the group B, even though group A population grew faster. But here, B loses the item, but B is not growing faster than C. Therefore, there is no population paradox. And the answer is, does the population paradox occurs using Hamilton method? The answer is no, it does not. Okay. Okay, that's the question number 4. Question number 5. Um, uh, Question number 5 is about new state paradox. That's new paradox here. Let's do that, and then have a definition here. The additional of the new group changes the apportionment of the other group. Notice that if you add new group on the existing group, the apportionment of other group changes. That's what the new state paradox is. Let's do the question number 5 to illustrate new state paradox. A corporation has 2 branches A, B. Each year, the company award 100 promotion within its branches. The table shows number of employee in branches. Remember that this is uh, uh, the company has 2 branches A and B, and first part of the question, use Hamilton method to apportion this 100 promotion. Okay, that's the first question. And again, if you do the Hamilton using standard divisor, you know how to find the standard divisor, because total population and number of quota, and you'll find that the apportion for A using Hamilton is 10, for B is 90. Therefore, 10 is the number of quota for A, or number of promotion for A. 90 is number of promotion for B. So 90 plus 10 is 100. Okay, now what happens? The group C, third branches, is added on the new group. Okay, now you have this is new group here, A, B, C. Okay, now when new group is added, number of promotion is also added. Therefore, when new group is added in the branch, the company added 5 yearly promotion for branch C. Okay, remember that when the C is added to the group, existing group A and B, C has 5 promotion also added. Therefore, here total number of promotion here is total number of promotion is 105. Remember that 100 was before, but when you add new group C, we add 5 promotion, therefore total number of promotion is 105. Now let's do the Hamilton again for this table with 3 group A, B, C with new group C. for 105 promotion, you get this. A gonna have 11 promotion, B gonna have 89 promotion, C gonna have 5 promotion. Notice that the 5 promotion for C. Okay, now let's see. We have a portion for each group, and does paradox occurs. Okay, where's the new step paradox definition here? The additional of the new group changes the apportionment of the other group. Does it happen here? Let's see. Since we add the new group C here, new group C, does the apportion of the other group changes? See, 10, 11, 19, 89. See, changes happen here. Therefore, the new state paradox occurs. Okay, the answer is, of course, B. Loses the promotion to the branch A. See, B has 90 before, now it's 89. But changes happen. If one loses, other must gain. That's why it happened here. Therefore, the answer is yes. Branch B loses a promotion to the branch A. Question number 6. A country has two state A with the population of 33,075 and B has a population of 316,925. Correct? The Congress has 100 seats divided between two states according to the respective population. Okay? Use Hamilton method to apportion the congressional seat to the state. Remember that. In the Hamilton method, you use standard divisor. You need the total population. There is no total population, but you can add this A and B population. The total population is 350,000. Okay, now find the standard divisor and do the Hamilton as we did before. And if you do the Hamilton, before you add new state, remember that we're adding 30 state in next part. Number of seat for A is 9. Number of seat for B is 91. Okay, 9 plus 91 is 100. Now suppose the 30 state C with the population of 36,400 is added to the country. Now you have this table here. You have A, you have a B, you have a C, and you have a total. Okay, what's the population of A? 33,075. Population of B, 316,925. C, we have here 36,400. And total gonna be, if you add this total, gonna be 386,400. Okay, again you do the Hamilton again. Use Hamilton method to apportion. How many here? Apportion 110, because 10 new Congress seats are added for C. Therefore, obviously for C you have a 10 here. And if you do the Hamilton using standard divisor, again, how do you find the standard divisor? Total population divided by number of item 1 to 110, and you will find this. You find 10 for A, you find 90 for B, and obviously 10 for C. Okay, now let's see. The question is, determine if new state paradox occur when the seats are reapportioned. Okay, see, we reapportion the seat with the new state. What happens here is, you can see that C okay, because C has a 10 congressional seats, right? But notice that other state here, 9 changes to 10, 91 changes to 90. Therefore, one state loses the seat, other state gain. That's the new state paradox. Okay, the additional of the new group changes the apportionment of other group. That's the new state paradox. Therefore here, yes, the new state paradox occurs because the state B loses a seat to the state A. Okay, the answer is this. Make sense? Alright, question 7 is also new state paradox. I did 2 questions for new state paradox. Okay, and you guys finish yourself for this question as well. Okay, and number 8, determine whether the following statement makes sense or does not make sense and explain your reasoning. Okay, what's the statement here? The population of state A grew faster rate than the state B, yet state A lost the apportion seat in legislature to the state B. Yes, this happened. That's the population paradox. This statement makes sense because this is the example of population paradox. Okay, that's the answer for question number 8. That's all about this section 13.4, the flaws of Hamilton method, pretty much. Okay, thank you.